So these 100 nanometer particles could get out, but they can't really penetrate. So if you put a drug in there, it's just going to kill the part of the tumor that's right next to the vessel. But then if you have something that can eat up that particle, like enzymes that happen to be present in the tumor, they can eat up that particle and dislodge smaller particles, and then can float around in the tumor and diffuse and deliver their payload to get rid of the cancer. That's the idea. It works great on a cartoon, but does it work in real life? First, we have to test it, okay? And the way we test it is by having the big particle be decorated with quantum dots. And we then image the 10 nanometer particles that are supposed to carry the payload because of the fluorescence of the quantum dots. So the quantum dots are a substitute then for the therapeutic carrier. And so we do our injection, the quantum dots diffuse throughout the tumor, validating their concept. And so what they're doing now is actually building real drug carriers based on the size scales that we imaged here. So let me switch gears completely now. Let me go to energy and lighting. We have a big problem with energy, not because we're running out of energy, but because we're dumping all this CO2 in the atmosphere. 22% of the world's energy is spent on lighting. A lot of our lighting comes from these sorts of bulbs, these incandescent bulbs. They were invented about 100 years ago. They're really old technology. When they were invented, they were amazing. They changed civilization. They allowed people to be able to read at night, to do all sorts of things. But it's a 100-year-old technology. In fact, it's a lousy technology. In fact, they shouldn't be called light bulbs. You know what they should be called? They should be called heat bulbs, because 95% of the energy you put in there comes out as heat. Just a few percent comes out as light. They're amazingly inefficient. Okay, so we're replacing our light bulbs with these guys here, these compact fluorescent lights. I don't like them. I don't like them for many reasons. They give out lousy light. They're full of mercury. They burn out if you put them in an enclosed fixture. You can't dim them. They're just as bad as this in many ways, right? Trash. Okay. The future of lighting really is not any of those. It's light-emitting diodes. They're little pieces of semiconductor that can emit very bright light and that don't burn out. And they're really tiny. And they're at least 10 times more efficient than incandescent, and they're getting more and more efficient. There's a problem though. Everybody wants to be like outside in the sun, and that's why we like incandescent, because the colors that come out of incandescent cover the visible. You have nice red. You look great under incandescent lights. LEDs, like the kinds that you can buy at CVS,